Today we're re-diving into a story that has had the astronomy community on the edge of its seat for months. It's a tale of high hopes, cutting-edge science, and the ever-elusive search for life beyond Earth. We're talking about the exoplanet K2-18b. Just a few months ago, this distant world, located about 120 light-years away, shot to astronomical stardom. Why? Because the incredible James Webb Space Telescope detected something tantalizing in its atmosphere, a molecule called dimethyl sulfide, or DMS. Now, why is DMS so exciting? Well, here on Earth, DMS is overwhelmingly produced by life, specifically marine phytoplankton. It's the compound responsible for that distinct smell of the sea. So, finding it on a distant planet, especially one that we know has water vapor and resides in its star's habitable zone, was a monumental development. The headlines were electric. Possible signs of alien life detected. It felt like we were on the verge of one of the greatest discoveries in human history. The initial data from the JWST was groundbreaking. It confirmed K2-18b is what we call a Hycean world, a planet larger than Earth, but smaller than Neptune, with a hydrogen-rich atmosphere and a potential liquid water ocean. This type of planet was purely theoretical until Webb started observing them. Finding methane and carbon dioxide was already a big deal, but the hint of DMS, that was the potential biosignature everyone was waiting for. It was the smoke that could lead us to the biological fire. The scientific community was cautiously optimistic. The original team that made the discovery was very clear. This was a preliminary finding. The DMS signal was weak, and they needed more data to be sure. But the possibility alone was enough to capture the imagination of the world. Could this be it? Could K2-18b harbor a vast global ocean teeming with microscopic life, all collectively producing this telltale gas? The implications were staggering. To confirm the finding, astronomers booked more precious time on the James Webb Space Telescope. They needed to stare at K2-18b for longer, gathering more light as it passed in front of its host star, a technique called transit spectroscopy. A longer observation would allow them to build a stronger, clearer signal and either confirm the presence of DMS beyond a shadow of a doubt or rule it out. The entire world was watching, waiting for the results of this follow-up investigation. Well, the new data is in, and unfortunately, it's not the news we were all hoping for. A new team of researchers, using 8 more hours of JWST's observation time, has conducted a far more detailed analysis of K2-18b's atmosphere. Their findings, which are currently undergoing peer review, paint a very different picture. According to this new analysis, the signal that was initially interpreted as dimethyl sulfide has all but vanished. When they combined the old data with the new, much more extensive dataset, the statistical evidence for DMS just wasn't there. It seems the initial hint was likely a statistical fluke, a bit of noise in the data that coincidentally looked like the signature of DMS. So, what happened? This is actually a perfect example of the scientific process in action. An initial, exciting observation is made. It generates a hypothesis. In this case, there might be life on K2-18b. That hypothesis is then tested with more rigorous experiments and more data. Sometimes the hypothesis is strengthened. Other times, as in this case, it's refuted. It's not a failure. It's a refinement of our understanding. The new study also brought another interesting twist. The team did confirm the presence of methane in the atmosphere, but they couldn't find any evidence for water on the surface. This has led them to propose a completely different model for the planet. Instead of a temperate, Hycean world with a liquid ocean, they suggest K2-18b might be a scorching hot lava world with a rock surface and a thick, gassy atmosphere. In this scenario, the methane wouldn't be from life, but from geological processes in a magma ocean. This is a dramatic shift in our perception of K2-18b. It's gone from being the poster child for habitable ocean worlds to potentially being a hellish, volcanic planet. It's a bit of a letdown, for sure. The dream of a living, breathing ocean 120 light-years away seems to have evaporated, at least for this particular planet. But let's not get too discouraged. This is far from the end of the story. Firstly, this new paper is still under review, and the original team will undoubtedly re-examine their own data in light of these new findings. The scientific conversation is ongoing. Secondly, and more importantly, this entire episode showcases the incredible power of the James Webb Space Telescope. Think about it. We are now capable of analyzing the atmospheric composition of a small planet orbiting a star over 1,000 trillion kilometers away. We can debate the presence of specific molecules in its air. That, in itself, is a monumental achievement. A decade ago, this was pure science fiction. Even if K2-18b isn't the oasis we hoped for, it has served as an invaluable test case. Scientists are honing their techniques, learning what to look for, and figuring out how to distinguish a genuine biosignature from a false positive. Every planet we study, whether it's a hit or a miss, adds a crucial piece to the puzzle. We are learning how to search, and the search is far from over. Webb has a long list of promising exoplanets to study. There are other Hycean candidates, other Earth-like worlds in the habitable zones of their stars. K2-18b was just one of the first and most tantalizing targets. The techniques refined here will be applied to dozens of other worlds in the coming years. The journey to find life beyond Earth was never going to be a straight line. It's a path filled with exciting leads, frustrating dead ends, and constant learning. The story of K2-18b is a perfect chapter in that grand adventure. It reminded us to be both hopeful and skeptical, to dream big but to demand rigorous evidence. So, while we might be closing the book on alien life on K2-18b for now, the quest continues. The universe is vast, and the James Webb Space Telescope is just getting started. The next groundbreaking discovery could be just one observation away. What do you think? Were you hopeful about K2-18b? Let me know down in the comments. Thanks for joining me on this cosmic journey today. It's through stories like this that we push the boundaries of knowledge. If you enjoyed this deep dive and want to stay updated on all the latest from the frontiers of space exploration, please hit that like button and subscribe to the channel. It really helps us continue making these videos for you. Until next time, keep looking up.